So today we're going to explain how to solve the Euler method for differential equations on a Casio calculator, specifically for the IB high-level mathematics exam. In this case, we're going to solve the mathematics analysis and interpretation for the time zone 1, summer 2024. In that exam, question 7 said, consider the differential equation dy divided by dx equals xy minus 1, given that y equals 2 when x equals 1. Use Euler's method with step size 0.1 to find the approximate value of y when x equals 1.5. So, Euler's method is an iterative method where we have to follow various steps, where the next value of x equals the previous value of x plus the step. The next value of y equals the previous value of y plus the step times fx n, and fx, the function f, is going to be the derivative. So these types of exercises are very easily solved on a calculator. We are going to go to the menu called recursion, option 8 here, and I click on x, and we're going to get these options. an plus 1 is going to be the x's, the next x's. bn plus 1 is going to be the next y's. So I'm going to first fill in the x's. I'm going to click here on F4, which is this value over here, and it allows me to enter an, bn, cn, and n. So we said that x, the next value of x, was the previous value, an, plus the step, and the step in this case was 0.1, because that was what they told us. So now let's fill in the y's. The next value of y, we said, was the previous value of y, f3, plus the step, which is 0.1, times the derivative. So now what we're going to do is, I'll open a parenthesis, and I'm going to directly write the derivative. But instead of x and y, I'm going to write an and bn. So that's going to be an times bn minus 1. Close the parenthesis. So that's nearly done. Now I'm going to go to settings, which is F4, 1, 2, 3, 4, F5, sorry. And I need to calculate where I start and where I end. We're going to start always in 0. If the start value is 1 and I want to finish in 1.5, that's 1, 1.2, 1.3, 1.4, 1.5. That's 1, 1.1, 1.2, 1.3, 1.4, and 1.5, which would be 6 values, but we're going to start in 0, so that's 0, 1, 2, 3, 4, and 5. We're going to finish in number 5. There would be no issue if you just select more values. The calculator would just calculate more. So I'm going to start in 0 and then in 5. And then we've been given a starting point, x equals 1, y equals 2. So a0 is going to be 1, b0 is going to be 2. Okay? And I'll leave the rest as that. And I'm going to go now to the table, which is F6. And here I get all the values, as you see, up until 1.5. Okay? So the first one, 0, is always going to be the starting values. And then as you see, 1.1, 1.2, 1.3. And for 1.5, I get a y of 2.876031104, which in 3 significant figures would be 2.88. But I always recommend to write the whole value of the calculator and then the 3 significant figures. And if we check the marking scheme, we get exactly the same value. And as they said, we'll write the whole values and then the 3 significant figures solution. So that's it. It's as easy as that. 4 marks, which are very easily obtained with a calculator, and we don't lose a lot of time. And as you see, 2, 2.1, 2.231, 2.3, 2.6, 2, 2.1, 2.231, 2.3, 2.6, and 2.86. So that's the whole table of iterations done in the calculator very quickly. So it's the sort of exercises that I recommend you to learn how to do, because if you get them in an exam, those are easy marks.